So for this question, some things that I'm noticing is that they told me the mean. They told me that their parent population is a normal distribution, which is okay. That's we'll find out later that doesn't really matter when we have this large a sample, but that's okay. So here's the mean, and here's the standard deviation for that parent population. Now, what's different about this is because I'm taking a sample of 87 trees, that shrinks that standard deviation, and we use this notation because we're dealing with sample means. The standard deviation for X bar, all the X bars, or standard error is another name for it, is you take your standard deviation from your population, and if you don't have the population standard deviation, you can always use the sample standard deviation. And I'm going to divide that by the square root of the sample size, because we're using the central limit theorem here. So if I calculate that, let's see, let me come back here and get, so I can click on the mouse, or click on the calculator. So 23.4 divided by the square root of 87, and that's the standard deviation for this sampling distribution. So what we know is, because the central limit theorem says the distribution of all the sample means are normal, not because the parent population is normal, but because we've got a pretty large sample size here. So because of that, we know the mean is the 88.8 from the population, and then all the sample results from all the same sizes of 87 vary around the standard deviation, or vary around that mean in a normal fashion. And the standard deviation is determined by the sample size. So if we take the parent population divided by the square root of 87, we'll get a smaller standard deviation, less variation in the results of the sample means. And that's what they're doing here for the answers. So I hope that helps you do it. Remember, it's the standard deviation from either the population or the sample, depending on what you have, divided by the square root of the sample size, ends the sample size. Again, this is true for sample means. Proportions have a different formula.